All right, good morning, and today we are going to be talking about polygons. So a polygon is going to be a closed plane figure, so 2D shape. It just means it's like flat on your paper, kind of like this. At least three straight sides and angles. Now, it doesn't have to be just three-sided, but the key thing is they have to be straight, and it has to be, right here, a closed figure, okay? So for example, if we had something like that, that is not a polygon. As soon as I put this fourth side here connecting it, that is. Also, if I had this, it would not be because it has that curved side. If I had something like this, it's not closed on itself, so those aren't part of it. Now, if I cover those up, I have a triangle there. Okay. And then the other word I want to talk about here, regular polygon. This is when it has congruent sides and angles. So all the sides and angles are congruent, then it's regular. Okay. Now, when we are naming a polygon, we can just choose any point on the edge, and then we just trace around it. So, for example, if I start with point V, I could do VPQRSTU or VUTSRQP. Either one of those would be fine. It doesn't matter which way you go. The key is you go in order. So polygon VPQRSTU, or I could start at V and go the other way. So VUTSRQP. Now I can't just start from V and then go to Q, then T. I can't bounce around. I have to go in order. Okay. Now, does this polygon appear to be a regular polygon? I'd say it does. It looks like all these sides are the same. So can we prove it definitively? Probably not. But does it appear so? Yes. Okay, now a couple of our polygons have some common names. For example, a three-sided polygon is a triangle. Now, a four-sided polygon, lots of you are probably going to be tempted to say a square. And that is an example of it, but our name that covers all of them would be a quadrilateral. Okay, because if we think about it, we are going to have rectangles, trapezoids, diamonds, rhombus. All of those are also quadrilaterals. Okay. Now, 5, think there's a building on the East Coast where our militaries ran out of called the Pentagon, right? 5-sided figure. 6, we're going to go hexagon. And we could keep going. Septagon, octagon, nonagon, decagon. But anything above that, we can just call an n-gon. Like if it was 13 sides, it'd be a 13-gon, okay, etc. So the next thing I want to talk about is how we find the area of some of these. So some of these polygons. So a triangle is one type of polygon, right? And hopefully you already knew this, but just 1/2 base times height. Now a rectangle is a type of the quadrilateral. So this is a polygon, but it's not all quadrilaterals are rectangles, but the area is just the length times the width. Okay. Meanwhile, the trapezoid, to find the area of the trapezoid, we have to take the height times the sum of base 1 and base 2 divided by 2. Now, on a trapezoid, our two bases are always going to be parallel to each other. If we look here, how do we find the perimeter of a pentagon? And I probably forgot a word that I should have put here, regular pentagon. As regular tells us all the sides are the same. So if it's a regular pentagon, that means there's 5 sides of length 3. So 5 times 3 will be 15 meters. Okay, now example 3. Find the area of a triangle with a height of 9 centimeters and a base of 4 centimeters. Okay, so a triangle, we know 1/2 base times height. So 1/2 times the base, which is 4, times 9. Half of 4 is 2. 2 times 9, 18 centimeters squared. And then our final one, find the area of, or the rectangle has an area of 24 inches squared and a length of 6 inches. So we know our area for our rectangle is just length times width. We already know the area is 24. We know the length is 6. So we divide that by 6. We'll find our width to be 4 inches. All right. Now as we go, we're going to skip over this. We talked about this some in class. Just keep the video a little shorter. I'm not going to talk about it too much here. If you have questions, let me know. Basically, if a figure is composed of two or more shapes, the area of the figure is the sum of the areas of the individual shapes. Okay, so if we think about that, what it's saying is if we divide this kind of up to a triangle, square, another triangle, if I would find those areas and add them up, I would have my answer. Yeah. Now, the next thing we're going to talk about, the Pythagorean theorem. Okay. So the reason I'm going fast through some of this is you should have already been exposed to it, but a squared plus b squared equals c squared. Now keep in mind, c is our hypotenuse. That is always going to be the longest side. It's also always the one opposite of the right angle. So here the missing side is our hypotenuse because it's opposite of the right angle. We know it'll be bigger than 5. So I can do 2 squared plus 5 squared equals c squared. 4 plus 25 equals c squared. I'll get 29 equals c squared. Now I have to take the square root of that. So c equals the square root of 29. I'm going to put this squiggle equal sign, meaning which is approximately. Now I'm going to open up a new tab. Go to desmos.com/scientific. You don't have to use this, but I recommend it. It's a good calculator that you can type in. So the square root of 29, I hit enter, I get 5.385. It keeps going. So approximately 5.4 will be our answer. So about 5.4. So that's our answer, and that is bigger than 5, so we know that is believable. Now on this next one, example 7, this missing side is down here. That's not the hypotenuse. It's either A or B. Our hypotenuse has to be 11 because it is opposite of the right angle. So if I do this, I'll do 3.9 squared plus b squared equals 11 squared. Now we hopefully know 11 squared is 121, but I don't expect you to have 3.9 squared memorized. So we go over here, 3.9, either raise the second or just hit this button, squared, get 15.21. So now we subtract that over from 121. So 121 minus the 15.21. And I get 105.79. Oops, wrong page. So 105.79. All right, at this point, take the square root. So square root of 105.79. And I get 10.285, etc. So if we round, about 10.3. Now our final problem for today, it is a trapezoid. To find the area, we will need to do the height times base 1 plus base 2 divided by 2. Now base 1, we can probably use right here, 15. Base 2, this whole length, so 6 plus 15 is 21, plus 6 is 27. Okay, so we can do the 15 plus 27 divided by 2. That'll be on the bottom. We still need the height, though. To find the height here, hopefully you notice either one, it's going to be the same. This is a right angle. It forms a right angle here. So we can use Pythagorean theorem to help us solve it. Now 12 has to be a C. It's opposite of the right angle. We don't know what this is, so 6 squared plus b squared equals 12 squared. 6 squared is 36. B squared. 12 squared is 144. We subtract that 36 then and have b squared equals 108. Take the square root of that, so b will equal about, so square root of 108, about 10.4. And that is our height. So now I can add that in here, multiply that. Now, first let's take care of the parentheses. So 15 plus 27 is 42, divided by 2 is 21. So 10.4 times 21, and that will give us our area here. So 10.4 times 21, we get 218.4. And our label, centimeters squared. All right, that's all I have for you. Go ahead to find your homework. I explained this in It's Learning, but go to your Wayne Learning Hub. Yours won't look exactly like this. Make sure you click on the one that looks like this logo, HMH. It'll pop up. Then you'll select, there's an option here called Assignments for you guys, and then you'll hit Start. It's 1.3 is the section. So I hope you guys have a great day, and if you need anything, let me know. Bye.